Good afternoon, YouTube. So this is the Canyon Trail Creek crossing. It's a lot higher than it was, a month or so ago when I last came up here. It's completely washed out. The old bit of the trail that people used to go on. Not sure how you get up there again. Probably over, you have to cross over there and then up, and then the trail is on top of this bank here. But that's the point of today's video. That bank of sediment there, that really doesn't belong up here. And you can see this whole bank here is just sand and silt, and there's some, smaller rocks, and over there, that whole bank there, that's lake deposits. Yeah, I'll come over here where I can get a little better view, but you can definitely see that bank there. That's probably a good 10 feet tall. So yeah, that I believe is lake deposits that was left when this creek was dammed up by the landslide that started maybe a quarter mile down the creek here. That's about where the start of that slide area is. And according to the 1973 geology report, in 1906, a half mile of this creek was filled by a landslide, and it came from up to 400 feet above the canyon and most likely dammed this creek up. And at this point here, this is the creek crossing. This is 1,182 feet elevation, and the top of the road where it goes over the slide area is 1,222 feet. So this is 40 feet below the level there, and that's where the canyon is really steep and deep. So this creek here backed up probably for at least a year and was 40 feet deep water at this point, and all that sediment came down the canyon from upstream and filled this whole area in. And I'll show you on the hillshade map how starting from here and going up over half a mile, maybe a kilometer upstream, this canyon floor is just flat as a billiard table, other than the stream channel cut through. The 06 earthquake was in late April 1906, and that's about the end of the rainy season here, so the creek level really starts dropping. There's very little flow after that. The creek, it may have been dammed up at least a year for it to fill up high enough here and flow over the top of that dam, and then it probably took a decade or so to cut through all that landslide debris and get back down here to this level. So I'm thinking it probably took more than one landslide dam to put this much sediment in the creek. So I'll show you a clip from the Stevens Creek Reservoir. There, the head section of that reservoir has been sedimented in pretty heavily in the last 80 plus years that the dam has been there. And it's taken 80 years of constant water flowing in and depositing sediment to sediment in that head section. Okay, this is the head end of Stevens Creek Reservoir. This is where Stevens Creek flows in. I think the reservoir is pretty much full to capacity, and this is about where the water starts backing up. It's a little over half a mile, maybe a kilometer downstream into the reservoir, where the creek has pretty much sedimented in this whole head end, and it's like this all the way down until you get to the deep part of the reservoir. So I don't know how deep the sediment is here, but this dam was built about 85 years ago. I think it was built in the mid-30s, and then it was raised in height to increase the capacity sometime after that. So this area here has probably been filling in with sediment ever since. So this probably didn't sediment in one go. It probably took many cycles of damming up the creek. The water fills up here, then the floods come down and drop all their sediment, and then it cuts through the dam, and then a couple hundred years later another slide comes down, blocks the creek, the water level rises, more sediment is built up. It starts filling at the upstream end, and then it gradually fills in down here, and you can see right in here the level is dropping. So this was probably the deepest part of the dammed up creek. That's basically a lake deposit here in a stream. So yeah, that would be a neat thing for somebody looking for a research project. Maybe do some core samples up there, or excavate the bank and see if there's multiple levels in there, because there should be like rhythmite levels in there. You'd have the fine sediment, and then it would get coarse, and then it would get fine and coarse as the energy of the water went up and down. Yeah, this water is a lot higher than it was a month ago. And the two guys I talked to said it's borderline uncrossable. They were soaked way up over the knees, so there's no way to to get across here gracefully. But yeah, there is that. So let's cut over. I'll show you on the hillshade map what this looks like. It's a lot more clear when you see it on the hillshade map. It just jumps right off the page. So let's cut over to that and we'll wrap this up. Okay, before we jump into the hillshade map, I wanted to show you this geology paper I've been talking about. It's called Preliminary Report 17 by Rogers and Armstrong, 1973. And if we go down here to page 26, it mentions there were many earthquake-triggered landslides in Stevens Creek and Saratoga Creek, which is the next creek to the south. Along the San Andreas fault zone, one landslide, reportedly 1/2 mile long, occurred on the northeast side of Stevens Creek, east of Table Mountain. This is the USGS map viewer here. Here's Table Mountain. Here's east of Table Mountain. This is the northeast side of Stevens Creek, and that's where the 1/2 mile long landslide was. Yeah, I think the multi-direction shows this a little better, but that's that big landslide scar that you can see from the trail. And then this whole stretch, probably from right about here and 1/2 mile long, would be down in this area. That was the extent of that landslide in 1906. And if you plug this canyon up, the creek stops flowing and it backs upstream, and you can see what happens when that creek backs up. Look at the floor of the canyon. It's just completely filled with the sediment I was showing you on the video. This looks like about the high water mark, or at least where the sediment started filling in, and it filled in all of this canyon all the way down here. Here's where the current trail crossing is, and then even down below here there's probably some sediment that was deposited here. This is the spot elevation function. I can come up here and there's an elevation right there, 1,205 feet. So that's a little below the very top end. I just wanted to get a spot I could click on. And here we are at the kind of the first bend of the creek. And let's see, we're down to about 1,198 feet. So in this stretch here, there's only 7 feet of drop. And let's get another elevation. This is the bar right before where the creek is cut through there, 1,190 feet. So you've got 8 feet of drop from here to here. And then let's get a click right in the bottom of the creek where the crossing is. Yeah, and right there it's about 1,180 feet. Right here between this bar and the bottom of the creek is about 9 feet of sediment that's been cut through by the creek there. Now if we come down here,
this is the stretch of creek again above the landslide. So if I click down here, and let's see, we're at 1166. So this is about, again, 15 feet of drop over that whole distance. Now if we come around here, let's see, this is the bottom of that landslide, and we'll click there, and you can see the creek's getting a little steeper. We've dropped now from 66 to 58. There's been 8 feet of drop just around 2 bends of the creek. And if we go over here, here's the base of that landslide that I started the video series with. And if you look down there, look at that. It's dropped to 1127. So it's dropped 30 feet just in that stretch of the creek right there. So that's a really steep gradient. It's probably a little over 300 feet of distance, maybe 400 feet. And let's look here. Here's the road that comes around the top of the slide. And if I pick a point there, that's the height of the bank here. So that's 1226. So it's about 100 feet of drop from where the road is down to the bottom of that portion of the creek, and it's about 70 feet down to this point. And you've got the meters there if you want meters. That's on the far right column. Let's see, we're 1228 here, and then the stream crossing there is 1181. So yeah, there's a pretty good drop between where the road is up here. The road's going upstream, but it's going downhill. And then the very headwater of that dammed up area was 1,205 feet. And that could have even been deeper, because to get the water to drop the sediment load, the creek has to flow into still water, and then that causes its speed to drop, and then all the sediment that it's holding falls out. So the high water mark could have been higher than 1,205 feet here. It could have been up to 1,226 feet, depending on how deep this canyon was filled up. You have the stream coming down from above carrying a sediment load. It hits the backed up water here, starts dropping coarse sediment, and then as it goes down, finer and finer sediment until it gets down here, and then it's the finest sediment. Right next to the stream crossing, there's a big sandbar down here, very fine sand and silt. So that fine stuff got all the way down here. Up here, it's probably larger gravel and rocks. That whole canyon's been filled in, and it starts filling from the upstream end, and then gradually fills in, and it pushes its way down. And the very last part to fill in is down here at the deepest part of the creek. And then at the same time, the creek is probably backed up here high enough, and it started flowing over the dam, and then starts cutting the dam down. And then at that point, this whole backed up lake starts draining. So the water, high water mark might have been here, and then it's here, and then it's here, and it works its way down as the creek cuts through the dam. So there's quite a dynamic process going on. And then you have to bear in mind that this creek, in drier years, it's very seasonal. There'll be a lot of flow in the winter months if there's a lot of rain, and at that point it can carry sediment. But in the summer, like the last few summers up here, it's been rather dry, and this creek dries up, so there's no sediment moving anywhere. So this sedimentation has to be just brief flood events. Yeah, and then to wrap up here in the video, I mentioned that it would be interesting to look for layering in the banks that are exposed along here. So about 1.5 years ago, I took a walk up this section of the creek when it was dry, and right along here there's a really nice bank exposure I didn't really know what I was looking at, but it looked interesting. I took this picture because the trail is up here. You can see these fence posts. But let's zoom in on this bank, and what do you see there? There's a band, a band, a band. There's many layers in this bank, and you can see here, here's the actual creek bottom, and then there's a little bit of rock up here. But once you get up here, it's a very consolidated bank, and you can see all of these layers, because what happens when that sediment is laid down, you'll have a big rainstorm. There's a lot of water in the creek. It's got a lot of energy. It's carrying big chunks, gravel and small rocks, things like that. And you'll get that, gravels and things like that. And then gradually, as the water depth builds and the creek is flowing less fast, and then over time, it'll turn into this lighter, finer material. So you'll get a layer of really fine stuff, and then coarse, and then fine. And you get different thicknesses depending on how long this lake was backed up. So right there, I think that is the smoking gun right there. But wow, I'm glad I took that picture a year and a half ago, because that has all the signs of repeated floods, sedimentation, and then the creek cuts a channel through it, and then it repeats. And you can see it's repeated maybe 10 times in there, depending on how many layers you want to count. But yeah, that is pretty impressive. So it finally makes sense what this is. So I figured I'd end there. That is my working hypothesis for why this part of Stevens Canyon is so flat. I mean, this is as close to billiard table flat as you can get. Thing is, if you look at the rest of the canyon, it's very steep and deep. But you come down here, and then all of a sudden, it's flat. But yeah, anyway, that is, I think, what's going on up here. Really dramatic view in this hillshade map, and this spot elevation feature just really show you what's going on. It's just incredible. So anyway, I thought I'd share that with you, and hopefully you found that interesting. And as always, thanks for watching.